So session 9.1.2, we're going to look at an arithmetic series formula. We're going to use this problem to help us figure out what the formula is. So let's find the sum of the integers 1 through 100 without using a calculator. Alright, a mathematician named Frederick Gauss came up with the following way to calculate the sum of the integers 1 through 100. 1 plus 2 plus 3 plus 4 plus ... plus 98 plus 99 plus 100. In a sense, just adding up the actual integers, but we're not going to actually add them. Then what Gauss did is he did the series backwards. He said 100 plus 99 plus 98 plus 97 plus ... plus 3 plus 2 plus 1. And he intentionally wrote the backwards series directly underneath the forward series. Because when we add each of these together, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. 98 plus 3 is 101. 99 plus 2 is 101. 100 plus 1 is 101. We now have 100 101s. If we multiply 100 times 101, that would be adding the integers 1 through 100 twice. We don't want to add them twice. So we're going to divide this by 2. So the sum of the first 100 integers comes out to 5,050. Now we can use this process right here, especially this piece, to get the formula for an arithmetic series. The formula that will be a shortcut for more difficult problems. So let's understand the part here that I've circled. The 100 came from the number of terms that we were adding together. The number of terms is represented by n. The 101 came from adding the first and the last terms together. Well, the first term of a sequence is u sub 1. The last term of the sequence, or the terms that we're adding together, would be u sub n. And then, of course, we divided that by 2. This gave us the sum that we wanted to come up with, or in a sense, the series S sub n. So we now have a new arithmetic series formula for finding a partial sum S sub n, where n is the number of terms, u sub 1 is the first term, and u sub n is the last term. Now we're going to put this formula to use in some examples, so you'll get to see how it is used. Find the sum of the first 75 even numbers, starting with 2. Alright, so let's start with our formula. S sub n equals n times the first term plus the last term divided by 2. Let's plug in what the problem is giving us. We are being asked to find the sum of the first 75 even numbers, starting with 2. So n is going to be 75, because that's the number of terms that we're being asked to add up. So S sub 75 is what we're trying to find. We can plug in 75 for the n. They tell us, starting with 2, so the first term is 2, plus u sub n. Now u sub n is the last term that we're adding together. That would be the 75th even number. I don't know what the 75th even number is, so I have to figure it out. But I'm not going to go 2, 4, 6, 8, 10, 12, and actually count out 75 of them. Although you could, you certainly could do that, but that might take some time. I'm going to think of this in terms of a sequence. To get the second even number, I take 2, and I add on 2, right, to get 4. To get the next even number, I add on 2 again to get 6. Then I add on 2 to get 8, then I add on 2 to get 10. I'm adding on 2 every time, right? It's an arithmetic sequence where I add on 2 every time. So if I think of this as a sequence, an arithmetic sequence, u sub n equals u sub 1 plus n minus 1 times the common difference. If you remember, this is our explicit formula for an arithmetic sequence. Now, since I'm dealing with even numbers, and the first number is a 2, and I'm going to add on 2 every time. This is my explicit formula. And I want to find the 75th even number, so that's u sub 75. So I'm going to plug in 75 for n. 75 minus 1 is 74. And now I can do 74 times 2, which is 148, plus 2, which is 150. So I just found the 75th even number is 150. Now that we found the 75th term, or the last term of the series, we can plug it in right here, 150, and then divide by 2. So we plug this into our calculator, and the sum of the first 75 even numbers is 5,700. In our second example, it asks us to find the sum of the first 40 multiples of 4. So, of course, if we had to, we could do 40 plus 8 plus 12 plus 16 plus 20 and keep adding up the multiples of 4. But, of course, you have to know when to stop. What is the 40th multiple of 4? Well, you have to know that. And that could be pretty time-consuming to add all those up, right? So instead, we're going to use our new formula. So we know S sub n equals n times u sub 1 plus u sub n all over 2. And we'll start by plugging in what we already know from the problem. We're finding the sum of the first 40 multiples of 4. So we're going to find S sub 40. We're going to plug in 40 for n right there. Multiples of 4, of course, we will start at 4, so that's our first term, 4, plus, and now we have to find this u sub 40th term, this last term. This is the point where we have to find the 40th term, so we think now in terms of a sequence. Okay, multiples of 4. So if we start at 4 and add 4 on, we get 8. Then we add 4 again and we get 12. Then we add 4 again and we get 16. So the multiples of 4 is actually an arithmetic sequence with a common difference of 4. So our explicit formula for an arithmetic sequence is u sub n equals u sub 1 plus n minus 1 times the common difference. Specific to our sequence, multiples of 4, we need to find u sub 40, the 40th multiple of 4. We know the first term is 4, and we are adding on a common difference of 4. I'm going to plug in 40 for n, so the use of 40 equals 4 plus 40 minus 1 is 39 times 4. So use of 40 equals 160. So now I can go back over here, plug in 160, divide it by 2, plug that all into my calculator, 3,280 is the sum of the first 40 multiples of 4. Our final example looks very much like the problems we did in the last lesson. We have the sigma notation here. We know sigma stands for the sum. We were being asked to find the sum of the 20th term through the 75th term of the formula 3n minus 5. Now, this problem is different from what we did in the last lesson, because all the problems in the last lesson started at n equals 1. And we had one problem that started at n equals 0. And the other issue that's different here is we're going all the way up to 75 here. All the other problems that we've done in the last lesson asked us for like the first 6 terms or the first 5 terms, where we could find those terms and just add them together. But this is a lot more. So how do we do this? Well, we're going to take the sum of all 75 terms of 3n minus 5. And we're going to subtract out the sum of the first 19 terms of 3n minus 5. And the reason that we are using the sums from the first to the 75th term and the first to the 19th term is because we can apply our new formula to it. We cannot apply that new formula to a sum that doesn't start at a first term. So we can't apply the formula to what they're asking us to find, but we can apply the formula to both of these. And so that's the next step of the problem. So we can think of this as S sub 75, which when we plug it into our formula, n is 75. The first term, we have to plug 1 into 3n minus 5. 3 minus 5 is negative 2 for the first term. Plus the last term, which would be the 75th term, we're going to plug 75 into 3n minus 5. So 220 divided by 2. So bring down our minus sign, and we're going to subtract. Now we're going to use the formula for the sum of the first 19 terms. So now n equals 19. Use of 1 is still negative 2. And use of 19, we have to plug in 19 for n. Get 52 for the 19th term, and then divide it by 2. I guess I should have wrote, this is the sum of the first 19 terms. I should have thrown that in there. So we use the calculator, we find out the sum of the first 75 terms is 8,175. And then we're going to subtract the sum of the next 19 terms, which is 475. And 8,175 minus 475 is 7,700. So that's the sums of the 20th through the 75th terms of 3n minus 5.